Hi class. Today we're going to study variation and do some applications with that. So let's get started. Okay, so our first example is an object's weight on the moon varies directly as its weight on the Earth. Neil Armstrong weighed 360 pounds on Earth with all his equipment on and weighed 60 pounds on the moon. What is the moon weight of a person who weighs 180 pounds? Okay, so varies directly means that the moon weight is equal to some constant times what they weigh on the Earth. Okay, so our first step is to find the constant by using the data here, the moon on the Earth. So he weighs 60 pounds on the moon is equal to some constant times 360. What he weighs on the Earth. So the constant K is just equal to, you divide by 360. Okay, and that's equal to 1/6. So the weight of the moon is equal to 1/6 times the weight on the Earth. So if a person weighs 180 pounds, then his moon weight will just be equal to 1/6 times 180, or 30 pounds. And that's basically how we do variation. Let's do another example. Okay. Well, I just saw this on the news today, or last night, and I realized there was a variation problem. So we have the number of minutes that you need to exercise by running to work off calories varies directly with the number of calories that you want to burn. Okay. If it takes you 28 minutes of running to burn off 290 calories, and that's the number of calories in a cup of mocha coffee. If you eat a pastry with 420 calories, how many minutes of running do you need to work that off? All right, very practical application. So let's see, the number of calories varies directly with the number of calories that you have to work off. Okay, so the time that it takes, time running, is equal to some constant K times the amount of calories that you consume. So to solve for K, we first use our first information. It takes 28 minutes of running to burn off 290 calories. So our constant K is just equal to 28 divided by 290. And we don't really have to simplify that. We could write it as some decimal. And that decimal is just equal to, take our calculator out, 29 divided by 290. And we could write this as 0.09655. So there's our constant. So now if we eat a pastry with 420 calories, how much time would it take? So time running is just equal to that constant, 0.09655, or we could write it as this fraction, times 420 calories, and that's equal to 40.5 minutes of running. Okay, 40.5 minutes of running. Maybe you don't want to have that pastry. Let's do another example. Alrighty. On a dry road, a car's stopping distance varies directly as the square of its speed. A car travels at 45 miles per hour can stop in this many feet. What is the stopping distance for a car traveling at 60 miles per hour? Okay, so the stopping distance varies directly as its speed. So the stopping distance, we'll just call it SD, is equal to some constant times its speed, we'll call that S. So we have to solve for the constant, so the stopping distance, 67.5 feet, is equal to K times the speed of 45 miles per hour. So our constant K is just equal to 67.5 divided by 45. And this time we'll keep it as, okay, we'll divide it out. 67.5 divided by 45. Okay, that's equal to 1.433. So our stopping distance for a car traveling at 60 miles per hour is just 433 times 60. And our stopping distance is going to be equal to 86 feet. Okay. And for our final example, a mammal, and this one's kind of interesting, a mammal's average lifespan, L, varies inversely as its average heart rate. If a cat has an average heart rate of 126 beats per minute and lives on average 15 years, then what's the average lifespan for elephants whose average heart rate is 27 beats per minute? Okay. Well, let's see. We have the lifespan varies directly as inversely as its heart rate. So we have some constant. Inversely means you're dividing by it. So average heart rate, I'll just call it H, the heart rate. So it's equal to some constant times 1 over H, or the constant divided by H. So now we have to solve for K. Cats live on average 15 years is equal to K divided by and number of heartbeats. The average heart rate was 126. So if we multiply both sides by 126, the constant K is just equal to 15 times that. 126 times 15 is equal to 1890. And so L is equal to 1890 divided by H, and there's our formula. So now, if elephants have an average heart rate of 27 beats per minute, it's just this divided by 27, and we get 70 years. Okay, well, I hope you enjoyed this video. It was helpful for your learning, and that you enjoy your learning. Cheers.